welcome back to my channel. Today we are going to learn how to write a lab report. So in this video, we will discuss on experiment 2A, free fall motions. So first, you must write the title, where title you will get 1 mark, and also the learning outcome. Determine the accelerations due to the gravity using the free fall motion, so you will get another marks. Okay, next we are going to refer to the data. Okay, height and also time taken, we call it as primary data, where we use the apparatus to do the measurements. Okay, so based on the data that we get, where H we use meter rule, so we need to write the uncertainty, meaning we must write plus minus 0.1. For time taken, we must write plus minus 0.001 second. Okay, so if you write with the correct unit and also with the correct uncertainty, you will get 1 mark. Okay, so for this part you will get 1 mark. Okay, for this part you will get 1 mark for the uncertainty and also the unit. Okay, next we goes to the secondary data, where secondary data is we calculate based on the primary data. So from here, T average is 0.301, and we want to sketch a graph H versus T squared. Therefore, we need to find out what is the value for T squared. T squared, if you times 0.301 squared up, you will get 0.091. And consistently 3 decimal place. Okay, so for T square, this is the secondary data. So for T square, either you must write 2 or 3 decimal places, meaning that if you want to write 3 decimal places, or the value T square, you must write in 3 decimal places. If you want to write in 2 decimal places, meaning 0.09, here you must write 0.11, 0.13 and so on, consistently with the decimal places. Okay, so if this one all you calculate correctly, you will get another 2 marks. Next one is we must refer back, okay, to the calculation part. So where for calculation part, first we should find the centroid. So we just take out all the value where we plot H versus T square, meaning that T square is our x-axis and H is our y-axis or y component. So we just copy down all the value and divided by 6. Similar for H, 45.0 plus 55.0, so we just copy down all the value divided by 6. Then we will get 0.142. Okay, so 0.142 here is better we write the unit as well per second square, and 70.0 also we must write the unit in cm. Okay, so if we observe here, actually for T square, our decimal places is 1, 2, 3. So here also we must write 1, 2, 3, follow back. For H, only 1 decimal places. Okay, 1 decimal place. So here, even though we write 70, but we must write 70.0. Okay, so if you write correctly, you will get 1 mark. Okay, here if you write with the correct unit also, you will get same, you will get 1 mark. Okay, so remember to write unit. Okay, remember to write unit. Okay, next one is we continue. Okay, we want to find the gradient. So after we find the centroid, we go to graph first. We go to the graph, where graph you have 11 marks for your graph. So first you must write your title. Okay, first you must write title. So title, you will get 1 mark. And then secondly, you must label exits with the correct labels and also units. So here H height plus minus 0.1 cm. Actually, you don't need to write the uncertainty. Okay, you just write the unit cm will do. So you will get 1 mark. and then t square unit is s square, you will get another 1 mark. Okay, so here already 3 marks. After that, you must have suitable scales. Suitable scales meaning that here, because our value is 100, so we will use 10, 20, 30, 40 and so on. Okay, and for our t square, we will use 0.04, or if you can use also 0.02. Okay, you can draw landscape. Okay, so if here you use 0.04, here will be 0.08, 0.120, 0.16 and so on. Okay, because our scales is until 0.200. Okay, so if this one, the scales that you use correctly, you will get another 2 marks. Okay, so here, you must refer back. The value here is 0.04. Okay, 0.04. Here is 0.04. So 0.04 here, we must take 0.04. So meaning that our uncertainty for the graph is 0.04, you divided by half of the smallest division. Okay, half of the smallest division. Here we have 10 small scale. We have 10 small scale. Okay, so when we have 10 small scale, you divide the half of the smallest scale, meaning that is equals to 20. Okay, so if you press calculator, 0.04 over 20, 0.04 over 20, we will get 0.002, meaning that we can read until 1, 2, 3 decimal places, 3 decimal places. Okay, whereas for y-axis, h 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, here 10 over half of the smallest scale. So the smallest scale is 10. So 10 times 2, meaning that we must divide it by 20. Okay, so 10 over 20, you will get 0.5. Meaning that for y-axis, we can read 1 decimal place. Okay, so this one, if you label correctly, you also will get 1 marks. Okay, next one is, we must plot at least 60% of the graph paper. So if you refer back to our graph, okay, your graph at least must have, your graph at least must have 60% of the graph paper. Okay, and also the triangle, okay, the triangle gradient must also greater than 50 cm, usually 50 cm, 50%. Okay, 50% usually is 8 cm, 8 cm. Okay, here 8 cm or 8 small scale. Here also 8 small scales. Okay, here. So 1, 2, 3, 4, 5, 6, 7, 8. Here also 1, 2, 3, 4, 5, 6, 7, 8. Okay, already over 8 cm or 8 small boxes. Okay, so this one you will get 1 mark. This one also you will get 1 mark. Okay, next one is, you must plotting centroid and also all the correct data. So centroid, okay, if you plot centroid, okay, you must circle it, and centroid you will get 1 mark. And all the 6 point, all the 6 point, okay, you will get 2 marks for all the correct point that you plot. Okay, all 6 point correct pointed, the plotted, so you will get another 2 marks. Okay, next one, best fit line through centroid, as many point as possible and balance point within the best fit line. Meaning that the line that you plot here, okay, line that you plot here, that you draw here, must pass through centroid, and also as many points as possible. So this line actually already passed through almost 5 to 6 points. Okay, and also balance meaning that the point on the both side is equally, okay, mostly equally. And bear in mind, okay, here is not necessary must pass through the origin. Okay, not necessary. Okay, based on the graph that you have. Okay, so it's not necessary you must always pass through the origin. Okay, so usually we plot or we draw the baseline is based on our plotting point. So meaning that 1 point is for a best fit line. Okay, so total is 11 marks. Okay, so we go back to just now. Okay, here, so remember for t square we can read until 3 decimal places, and for y exit meaning h we can read 1 decimal places. Okay, so based on the gradient that we plot, okay, the gradient that we find here, we go back to just now the calculation part. Okay, so for calculation part, we can read for y-axis, we can read only 1 decimal place. Let's still remember 1 decimal place, so it's 90.0. Even though it's 90, but we must write also 90.0. Similar for our y1, okay, 10.0. Okay, so meaning that you must write 1 decimal places here minus 1 decimal place. Okay, for x-axis just now we know that we can read until 3 decimal place. So 0.180 we cannot write 0.18 because we must write 3 decimal place based on the scales that we read just now, the half of the smaller scales. Here we must write 0.020. Okay, so now we take 90.0 minus 10.0. Okay, so here we will get 80.0. Okay, so now this is involve 90.0 minus 10.0 over, okay, it's divided. So when we say divided, we must base on we will take the smallest significant figure. Okay, so here our 90 is actually 3 significant figure, 10 also 3 significant figure, 0.180 here also 3 significant figure, 0.020 is 2 significant figure. Okay, so when we say divide, we will take the smallest significant figure. Okay, so smallest significant figure, therefore we will take 500. Okay, it's impossible we take 50. Yeah, okay, we must write 500. Okay, so the unit is, because just now y is in cm, h is in cm, and t square is second square. So therefore our unit is cm per second square. Okay, cm per second square, or we can convert. Okay, 100 cm actually equals to 1 meter. Okay, so we can change it become 5.0. Here we must write 5.0 enough because 2 significant figures. So 5.0 meter per second square. Okay, so how can we get marks? Okay, if you substitute the value here, correctly with the correct decimal places from the graph, you will get 1 mark. And here, if you correctly state just how many significant figure with the correct unit, with the correct significant figure, then you will get another mark. Okay, so here 1 mark, and the final answer for the gradient you also will get 1 mark. Okay, so here 2 significant figures, so it's 2 significant figure. Okay, next one we will go to, okay, after find the gradient, we will compare. Okay, compare with our equation. Compare with our equations, where our equations given h equals to half gt squared. So if you compare y equals to mx plus c, h is y-axis, t square is x-axis. So meaning that our gradient, okay, gradient here is equals to half g. Okay, is equals to half g. Okay, so therefore our gradient, if you compare with the equations, m is equals to half g. Okay, but the objective is we want to find the g, right? So we will take g as a subject. So g will equal to 2m. M is the gradient, so we substitute inside. So this one you don't need to write. So 2 times 5.0. Okay, 2 times 5.0. Okay, so 2 times 5.0 again, because it's involved a multiplication. So 2 is one significant figure, 5.0 is two significant figure. So we will take either 1 or we can take 1 plus 1 plus 1. Okay, so you can take 10. Okay, here you don't need to write 10.0, you just write 10 enough. 10 enough. Okay, so how can we get marks? So if you substitute correctly, you will get 1 mark. And then the final answer with the correct unit, you will get 1 mark. Okay, next one is percentage of difference between the experimental value. Okay, after we obtain the value of the G, the value of the accelerations due to gravity, so we must compare the difference between the experimental value and also theoretical value. As we know, theoretical value is 9.81. Okay, so we take theory minus experimental value with modulus, because we only want to take the differences between the experimental and theoretical value. So we just modulus, okay, over theory times 100%. So remember to write 100%, percent. Okay, so the symbol percent you must write. So we take 9.81 minus 10, okay, over 9.81. So our value, if you press calculator, you will get roughly 1.94. Okay, or you can write 1.9. Okay, 1.9%. Okay, so this one, if you correctly, you will also get 1 mark and 1 mark for your substitution and also the value that you find. Okay, next one is, okay, after finish, we can go to the discussion part. So for discussion part, usually we divide it by 3 parts. The first part is you must write the report writing. Okay, report your result. B is the errors and also mistake. C is the precaution step or ways to overcome. So the first one, theoretical value 9.81. Okay, experimental value, you will get 10. And then percentage of difference, just now we already found 1.94%. And then errors, okay, first you can say parallax error. Okay, you say our eye view is not perpendicular. Okay, and then next one you can say because of the air resistance. Okay, so precaution step, usually we must base on what is the errors. We must take the precaution step. For example, let's say you say parallax error, the first one. So this one you must say our eye view must perpendicular to the scales. Okay, the second one is when you say air resistance. So the precaution step, you must say you must switch off the fan. Okay, you must switch off the fan to reduce the effect of air resistance. And then we comes to conclusion. Okay, just now the discussion part. Okay, discussion part, you will get a few marks for discussion part, where if you report all correctly, this one you will get 1 mark. Okay, 1 mark. This one you will get 1 mark. Errors and precaution also you will get 1 mark. Okay, so this precaution step also you will get 1 mark. Okay, last one is the conclusion. Okay, so conclusion, you must report back. Okay, report back what is your finding. Okay, based on the experiment, the result that we get. So the report, right, the conclusion here is, okay, the conclusion here is the theoretical value. Okay, the theoretical value that we get, okay, is 9.81. And then the experimental value is what you get is 10 meter per second square, and the percentage of difference is 1.94. So bear in mind that if the percentage of difference less than 15% from the theoretical value, we consider is a good result. Okay, it's acceptable. Okay, after that we make conclusion. The acceleration due to gravity can be determined using free fall motions. Okay, so that's all for the experiment. Okay, so this is the photo where this is the home-based experiment. Okay, so that's all for today. Okay, see you on next video on the next report writing for experiment 2B projector motion. Okay, thank you, bye, and have a nice